Okay, last thing that we have to take note on today is thermochemical equations. That is spelled like so. Thermochemical equations. This I'm going to do pretty briefly today, and we'll review it either on Monday or on Tuesday when we get back. But this is essentially stoichiometry. Okay? And you guys have gotten good at stoichiometry. You're good at doing your conversions from moles to mass. It's very easy. Okay, it's the same thing. So what a thermochemical equation looks like, and we talked about this a little bit when we talked enthalpy, is that we can also write heat within a reaction. So here are two examples of that. I have heat, in the first one I have heat in my products, and in the second one I have heat in my reactants. The placement of heat tells you whether something is endothermic or exothermic. So when heat is in our products, this is an exothermic reaction. And then when heat is part of our reactants, that is a endothermic reaction. Okay, again, that's what we talked about on, that would have been on Wednesday. We talked about that. Okay, exothermic and endothermic. Now, what else we can do with these is we can also look at the mole ratios. So right now, I just put everything as 1 to 1. But for right now, we could say that for every 1 mole of A, there is this much heat. And for every 1 mole of E, there is this much heat. Okay, so now we're going to look at this with mole ratios. Okay, let's draw out an example. We're going to do this first example just with symbols like this. A plus B yields C plus 90 kilojoules. We know that this is exothermic because our heat is our product, is one of our products. And then let's see if we can answer this question. If we have 2 moles of A, how much heat do we have? Okay, if we have 2 moles of A, how much heat do we have? What we can see, now you might not even need to do any of the math to figure this one out, but you can see that I have 1 mole of A gives me 90 kilojoules. So if I have 2 moles of A, I just have to multiply that by 2. Now that's easy when you're just looking at that easy ratio right there, but sometimes it's going to be a little more complicated, so let's write it down like we have to set it up. So we always start with what we're given, which is 2 moles of A, and then we draw ourselves our train tracks. My conversion factor is for every 1 mole of A, there is 90 kilojoules. Now remember, the reason that 1 mole of A went on the bottom was so that moles of A could cancel. I multiply everything on top, divide by everything on the bottom, and I get 180 kilojoules. Okay, so it's just like stoichiometry. This is for every 1 mole, there is 90 kilojoules. Now I could do the same thing. I could have said if there were 2 moles of C, that would have also given me 180 kilojoules. Let's try one with an actual reaction. So let's try hydrogen gas plus oxygen gas makes water, plus 60 kilojoules. Go ahead and write that down. And tell the person next to you whether that is an endothermic or exothermic reaction, and how do you know? Go ahead and pause right now and do that. You should have said that this is an exothermic process because your heat is produced. It's one of your products. Okay, exothermic. Now let's see if we can answer this question. If I have, now in this reaction right here above, I produce 60 kilojoules of heat. What if I produce 140 kilojoules of heat? How many moles of hydrogen did I use? So in the problem before, right, in the example that we did before, that time we were given moles and we were finding heat. We can also do it the opposite way, where we're given heat and we're finding moles. So as always, we start with what we're given, which is 140 kilojoules. And this time, in order to get from heat into moles, I'm going to use my mole ratio here. There are 60 kilojoules of heat. That's going to have to go on the bottom so that kilojoules can cancel for every 2 moles of hydrogen. So 60 kilojoules of heat goes on the bottom. 2 moles of hydrogen goes on the top. The kilojoules will cancel. I multiply everything on top, divide by everything on the bottom, and I get 4.67 moles. Again, I had to put that 2 right here because there are 2 moles of hydrogen up here for every 60 kilojoules. All right, let's make this one, let's take this one step further. These are probably the hardest type of problems that you'd have to do. What if I gave you grams instead of moles? So let's say I said I have 38 grams of oxygen and I want to know how much heat I produced. Go ahead, like always, and start with what you're given. Now, the question that I've always asked you during any sort of stoichiometry thing is I can never convert from one thing to another without first converting to moles. So right now I'm in grams and I need to get myself into moles. You guys are good at that by now. All you have to do is look at the periodic table and find the molar mass. So I look up on my periodic table and I find that the molar mass of oxygen is 32 grams of oxygen for every 1 mole of oxygen. At this point, my grams of oxygen would cancel. Now that I'm in moles, I can use my ratio up here, that for every 1 mole of oxygen, there are 60 kilojoules. 1 mole of oxygen is going to go on the bottom so that moles of oxygen can cancel. 60 kilojoules will go on the top. So now my only unit I'm left with is kilojoules, which is good because I'm trying to solve for heat. When I solve that problem, I get 71.25 kilojoules. Okay, I think that some of you are ready for that, and if you were, that's great, then you are ready to keep going in your homework. Others of you will need to see that again, which is fine, because we'll have time to do so. This means that next week, all we have to do is Hess's Law, and then review thermochemical equations if we need to, and then we're ready to review and test on Thursday. Okay, you can now do everything in your homework packet except for the Hess's Law stuff. So the rest of the time in class is yours to work. If I don't hear that you are working, then we will keep moving on even faster next week, and we won't have as much review time. If I hear that you are working well the rest of the hour, then I'll make sure to plan in plenty of review time for your last big test of the quarter. Have a great weekend.